So hello everyone, welcome back to my channel, and today we'll look into the topic environmental regulation with moral hazard. And in this topic I shall discuss a model of incentive with the single polluter and the regulator. So this is some kind of principal agent problem. So in my last lecture on the case of adverse selection, we considered a case in which the emission cost is unknown to the regulator. But here we'll start with some different scenario in which the action of the polluter is not observable. So for example, if we take the case of emission, the emission by a firm is not properly observable. So if the regulator wants to observe or monitor the emission, it will incur a huge cost. So that is the major problem here. So here we consider that the polluter itself reveals reveals the information regarding the pollution. So in this case, what we see, we will use a simple model. So this is some kind of principal agent problem. So who is the principal? So EPA, or the Environment Protecting Agency, it plays the role of the principal, and the polluter, he is the agent. So EPA does not have clear information on the pollution, and for the information of pollution, it has to depend upon the polluter who reveals the information on emission voluntarily. But one thing you have to understand here, the EPA cannot verify whether the polluter is providing the authentic information or not. So we'll start our analysis from here. So whenever we are talking about the controlling of the pollution, we have to understand one thing, that controlling pollution depends upon two things. So let's come to the point of pollution control. Who is controlling the pollution or emission? The polluter is controlling the emission. So regulator, with on the basis of the given constraints, especially the information problem, regulator has to frame some regulation to optimize the entire situation. So first, if we start with the pollution control, it depends upon two things. So number one, what we call the setup for abatement, or what we say setup or the equipment. We call it A. So this is the first thing. So this setup or equipment, that is observable by the regulator. So regulator can easily observe that what setup the polluter is installing, what machineries are being purchased by the polluter, what pollution control unit have they set up. This is completely observable. And also the regulator can issue some regulation regarding this. So for minimum abatement to the setup, what are the machineries, what are the equipment to be purchased. So everything can be dictated by the regulator here. And polluter has to abide by the norms of the regulator. This is one thing. So this setup, this is under the control of the regulator or EPA. But now second thing is that effort. So not only the setup plus effort, how much effort is given by the polluter, that also matters. So what we see here, if we look at the emission, the total emission, the emission is a function of A and F. So definitely if A rises, that emission will fall. So and also if F rises, the emission will fall. So both. So what we say here, we can say here, given the equipment or the abatement setup, if the farm gives more effort, it can control the emission. The volume of emission will be lower. So similarly, given the effort, if there is better equipment or better abatement cost or higher abatement cost, that will also control the emission. So the volume of emission will decline. So emission is inversely related to both A and F. Now, so here first we will consider the problem of a polluter and then we'll consider the problem of a regulator here. So just think from the perspective of the polluter. The polluter has a cost function of abatement or pollution control. So how can we define the cost function? Definitely the cost function, the cost will be determined by A and F. So the level of abatement or the abatement setup as well as the effort given by the farm or given by the polluter to control pollution. This is fine. But we here consider, for the sake of simplicity, will consider that the cost function in which what we say that A is independent of F and F is independent of A. So A and F are independent of each other. This is a very crucial point here. So what we can write here, the cost function, the entire pollution control cost can be given as C1 function of A plus C2 function of F. So we place the total cost in an additive form. So now what we see here, we have to, the objective of the polluter is to minimize the cost. Remember that. So polluter will try to minimize the cost. Now question is that we have two different variables that affect the cost of emission. The question is that which one is under the control of the polluter. So definitely the abatement or the setup or equipment, that is dictated by the regulator. So instead of A, we can write A equals to A bar. So A bar is, so what we see here, the abatement setup or equipment, that is exogenously given. That is not endogenous for the farm. So which one is endogenous for the farm? Obviously, the volume of effort. And what we can say here, let us consider there is some upper limit and there is some lower limit of the effort. So what we see here, the F that is greater than equals to FL, the lowest effort, and this is the less than equals to FU, the upper limit. So lower limit, upper limit. So the firm has to choose a specific level of F so to minimize its cost of pollution control. Now, if we think from the perspective of a firm, the firm knows that I have to bear the specific cost which is dictated by the polluter. But another thing is that we have to remember here that the polluter has no idea about F. So even if the firm gives the minimum effort, that will not hamper its relationship with the regulator. So this is the most important point here. So what we see here, the firm's objective is to minimize C equals to C1 A bar plus C2 F with respect to F. So farm has to choose the level of F for which the cost is minimum, and that is possible if F equals to Fu. And what we see here, as per our condition, that F is not observable by the regulator. So this is very crucial point here. So farm always try to minimize his effort or give minimum effort, because this is the problem of moral hazard. The firm intentionally cheats with the, what we see here, the agent. Firm is the agent and polluter is the principal. So firm is the agent is cheating the principal, taking the advantage of the fact that F is not observable. Now, we have to think from the perspective of the regulator, and only after that we can find which is socially optimal and how is the moral hazard responsible for a suboptimal level of abatement. So let's come to that point. Now think about the regulator. So regulator wants to minimize the total cost. So remember, we have to remember that regulator has to think about the society, the social benefit, social damage, as well as the cost borne by the farm to control pollution, because farm is also a part of the society. So if we frame the problem of the regulator wants to minimize what? Total cost. Now what will be the total cost? So we can write here that social cost is the function of the CF and CA and F abatement cost plus the damage. So DC, which is the function of emission. So now what we see here, emission is the, so first we have to find out, I have already said about this. Now let's consider this cost of damage to the society caused by emission. So what we see here, if E rises, that means the cost of damage will increase. Because if there is more emission, that will create more pollution, more concentration of greenhouse gases, other pollutants in the atmosphere, and that will cause some social damage. So that's why what we see here, DC is positively related to E. But we have to find out here what we are considering, the equipment or the abatement and the effort. So we also have to relate the cost of social damage to abatement and effort. And what can we do for that? The easiest way is to find out the indirect function. So what we can write here, the DC is the function of E. So we can write here DC is a function of E, which is a function of A and F. And we have already known that E is inversely related to A and F. So we can write here DC is a function of A, the equipment for abatement setup, and the effort, and DC is inversely related to both A and F. So we can write here the del DC, del A less than 0, as well as del DC, del F less than 0. So now we have to consider the optimization function of the EPA or the regulator. So regulator wants to minimize the cost. So what we can write? So social cost equals to C of, so we can write here C1A plus C2F plus DC A and F. Now, if we look at the social cost function, there are two independent variables. The independent variables are A, the abatement setup, and the effort, or what we call F. Now, Think from the perspective of the regulator. Regulator has no idea on F because it is very difficult for the regulator to monitor whether the firm is giving proper effort or not. So this effort is completely unobservable for the regulator. So that's why what will the regulator do? The regulator will try to find out the level of abatement or A for which the social cost will be minimized. And for that, what we have to do? We simply have to take the first order differentiation with respect to A. And definitely it will be a partial differentiation. So what we can write here? Del SC, the first order condition says del SC by del SC del A equals to 0. So what we can write? Del C1 del A plus del DC del A equals to 0. So on other words, we can say del C1 del A equals to minus del DC, sorry, minus del DC del A. So this is left hand side indicates what? Marginal cost. And right hand side indicates this is the marginal cost of abatement faced by the firm, and this is the marginal cost of social damage. So right hand side we see what there is a negative sign, but need not worry about that because the first order derivative of dc with respect to a, that is negative. So whenever negative is multiplied by negative, it will become positive. So this is the right hand side is called the marginal damage function. And what we see here, as the abatement rises, marginal damage to the society or the cost of marginal damage will decline. So this is what we see here in the left hand side. What we see, as there is a higher, better abatement setup, the cost of abatement will increase for the firm. And right hand side says, as the abatement increases, the marginal damage to the society will decline. So here, what we can see that the equilibrium level of abatement or the A equilibrium level of A can be determined by the intersection of these two curves. So in vertical axis, we are measuring the value. In horizontal axis, we are measuring the total volume of abatement or the equipment or the setup for pollution reduction or the emission control. So what we see here, this is the MC1A and this is the minus del DC del A when F equals to F star. So this is the equilibrium level of abatement. So what we see, F star here considered as the socially optimal level of effort. So this is the, so E is the equilibrium and O A star is the socially optimal level of A. What we say? The equipment to control emission. So this is the fact or equilibrium point E can be achieved if and only if the effort by the firm is at its socially optimal level, which is very much unlikely in the real life because the polluter will always take the advantage. Advantage of what? Advantage of the fact that the effort is unobservable by the regulator. So the polluter will always give the lowest effort. And if there is the lowest effort, so what will happen? We know that the damage is inversely related to the effort. So whenever there is the lowest effort, damage will increase. So we'll get another curve that is del dc minus del dc del f when f equals to fl. So as fl is less than f, this curve will be upper. So considering the case that the firm is not, the firm's effort is not at its optimum level, considering the fact that the firm is giving minimum effort, the polluter has to, the regulator has to compensate it by what? By dictating a higher setup for pollution control. So that's why what we see, the equilibrium setup, the actual, this is the socially optimal equilibrium, which is the called the best solution. But this will not be achieved because of the problem of moral hazard. The firm is not giving the socially optimal level of effort. Rather, it is giving the lowest effort. So what we see here, the actual equilibrium will be a double star, which corresponds to the minimum effort given by the firm. So what we see here, because of the existence of moral hazard, or the because of, this is a principal agent problem, the agent is basically cheating the principal and the principal cannot detect it because of the high monitoring cost, and the pollution emission is also unobservable to the regulator. Remember that. To the regulator, both emission and effort are unobservable. The only observable thing is the pollution control setup that the polluter adopts. So that's why what we can see that due to the existence of moral hazard, the regulator has to compensate it by dictating a higher setup than the socially optimal level. The question is that is not there be any solution of it? The answer is no. There is no proper solution of it because there are some solutions which are imperfect in nature. So maybe the which are observable. So maybe the regulator can check how many people are engaged in pollution control mechanism, or the they can also observe what is the maintenance cost on this setup, but there is no exact equipment or though no exact method to find out whether they are giving the proper effort or not. So because that's why, yeah, we will always find a suboptimal level of suboptimal value of A. So the best socially optimal solution is far beyond to be achieved. So this was today's lecture. So we end here, and very soon I'll come with some new lecture on some new topic.